Boom, boom. Let's see. One, two, three. We are live. Oh my goodness. Watch. Now, just to prove to you we're live, I'm going to play this one again just so we can have some fun. Wait for it. Wait for it. You ready?
Yes, I am.
Whoa. How good
Amazing.
is that? How cool is that? Noé, great to have you here, everyone. We are back for another Vector Space Talks, and today we are joined by my man Noé, who is the lead data scientist at Sicara. And if you do not know, he is working on a wide range of projects, mostly related to computer vision. And today we are talking about navigating the complexities of vector search. We're going to get some practical insights from diverse projects in image search and everyone's favorite topic these days, retrieval augmented generation, aka RAGs. So, Noe, I think you got something for us. You got something planned for us here.
Yeah, I do. I can share them.
All right. Well,
Thank you
I'm
very much for
happy,
this.
very happy to have you on here, man. I appreciate you doing this. And let's get you sharing your screen so we can start rock and rolling.
Okay,
Cool.
can you see my screen?
Yeah, awesome.
Great. So thank you, Demetrius, for the great introduction. So I just completed quickly. So as you may have guessed, I'm French. I'm a lead data scientist at Sicara. So Sicara is a service company helping its clients with in data engineering and data science, so building projects for them. Before being there, I worked at Realytics on optical character recognition, and I'm now working mostly on as you said, computer vision and also Gen AI. So I'm leading the Gen AI side, and I've been there for more than 3 years. So some relevant experience on VectorDB is why I'm here today, because I did 4 projects, 4 vector search projects, and I also wrote an article on how to choose your database in 2023, your vector database, and I did some related talks in other conferences like PyData, GVC, or the GenAI meetups of London and Paris. So, what are we going to talk about today? First, an overview of the vector search projects, just to also to give you an idea of the kind of projects we can do with vector search. Then we will dive into the specificities of the image search project, and then into the specificities of the text search project. So here are the 4 projects. So 2 in image search, 2 in text search. The first one is about matching objects in videos to sell them afterwards. So basically, you have a video. We first detect the object, so like it can be a lamp, it can be a piece of clothes, anything. We classify it, and then we compare it to a large selection of similar objects to retrieve to a large collection of like sellable objects. The second one is about deduplicating real estate adverts. So when agencies want to sell a property, like sometimes you have several agencies coming to take pictures of the same good. So you have different pictures of the same good, and the idea of this project was to match the different pictures of the same good, the same
I've
property.
seen that. Dude, I have been a victim of that when I did a little house shopping back like 5 years ago. It would be the same house in like many different ones. And sometimes you wouldn't know because
Exactly.
it was different photos. So I love that you were thinking about it that way. Sorry to interrupt.
Yeah. So to be fair, it was the idea of my client. So it's basically, I talk about it a bit later, but it's aggregating all the adverts and trying to deduplicate them. And then the last 2 projects are about RAGs, retrieval augmented generation. So the idea to be able to ask questions to your documentation. The first one was for my company's documentation, and the second one was for a medical company. So different kind of complexities. So now we know all about this project. dive into them. So regarding the image search project, to compute representations of the images, the best performing model from the benchmark and also from my experience is currently DinoV2, so a model developed by Meta that you may have seen, which is using visual transformer. And what's amazing about it is that using the attention map, you can actually segment what's important in the picture, although you haven't told it specifically what's important. And as a human, it will learn to focus on like the dog on this picture and do not take into consideration the noisy background. So when I say best performing model, I'm talking about comparing to like other architecture like ResNet, efficient nets models. An approach I haven't tried, which also seems interesting. If anyone tried it for similar project, please reach out afterwards. I'll be happy to talk about it. Is SIFT for I'm not even, it's feature transform, something about feature transform. It's basically a more traditional method without, it's not learned features through machine learning, as in you don't train the model, but it's more traditional methods. And you basically detect the different features in an image, and then try to find the same features in an image which is supposed to be the same. We see that all the blue line trying to match the different features. Of course, it's made to match image with exactly the same content, so it wouldn't really work, probably not work in the first use case, because we are trying to match similar clothes but which are not exactly the same one. And also it's known to be not very resilient with the changes of angles when it changes too much, etc. So it may not be very good as well for the second use case. But again, I haven't tried it, so just leaving it here on the side. Just a quote about how Dino works, in case you're interested. So it's a vision transformer, and it's trained in an unsupervised way, as in you don't have any labels provided. So you just take pictures, and you first extract small crops, and augment them, and then you're going to use the model to compute vectors representations of each of these crops. And since they all represent the same image, they should all be the same. So then you can compute a loss to see how they diverge, and to basically train them to become the same. So this is how it works, and the difference between the second version is just that they use more data sets and the distillation method to have a very performant model, which is also very fast to run. Regarding the first use case, so matching objects in videos to sellable items. For people who used Google Lens before, it's quite similar, where in Google Lens you can take a picture of something and then it will try to find similar objects to buy. So again, so you have a video, and then you detect one of the objects in the video, put it and compare it to a vector database of which contains a lot of objects which are similar for the representation, and then it will output the most similar lamp here. Now we're going to try to analyze how this project went regarding the positive outcomes and the changes we faced. So basically what was great is that Dino manages to understand all objects and clothes patterns without fine-tuning. So you can get an off-the-shelf model and get started very quickly and start bringing value very quickly without having to go through all the fine-tuning processes. And it also manages to focus on the object without segmentation. What I mean here is that we're going to get a box of the object, and in this box there will be a very noisy background which may disturb the matching process. And since Dino really manages to focus on the object that's important on the image, it doesn't really matter that we don't segmentate perfectly the image. Regarding the vector database, so this project started a while ago, and I think we chose the vector database something like a year and a half ago. And so it was before all the vector database hype, and at the time the most famous one was Milvus, the only famous one actually. And we went for an on-premise deployment, and actually our main learning is that the DevOps team really struggled to deploy it because basically it's made of a lot of pods, and the documentations about how all these pods are supposed to interact together is not really perfect, and it was really buggy at this time. So the client lost a lot of time and money in this deployment. The other challenges we faced is that we noticed that the matching wasn't very resilient to large distortions. So for furnitures like lamps, it's fine. But let's say you have a trouser, and a person walking, so the trouser won't exactly have the same shape. And since you haven't trained your model to specifically know it shouldn't focus on the movements, it will encode this movement. And then in the matching, instead of matching trouser which looks similar, it will just match trouser where in the product picture, the person will be walking as well, which is not really what we want. The challenges we faced is that we tried to fine-tune the model, but our first fine-tuning wasn't very good because we tried to take an open source model and get the labels it had, like on different furnitures, clothes, etc., to basically train a model to classify the different classes, and then remove the classification layer to just keep the embedding parts. The thing is that the labels were not specific enough, so the training task was quite simple, and at the end, the embeddings was not learning any very complex features, so it was not really improving it. So jumping onto the areas of improvement, knowing all of that, the first thing I would do, if I had to do it again, would be to use the managed Milvus. For better fine-tuning, it would be to label hard examples, hard pairs. So for instance, you know that like when you have a matching pair where like the similarity score is not too high or not too low, you know it's where the model kind of struggles, and you will find some good matching and also some mistakes. So it's where it kind of is interesting to label to then be able to fine-tune your model and make it learn more complex things according to your tasks. Another possibility for fine-tuning will be some sort of multi-label classification. So, for instance, if you consider a top clause, you could say, all right, does this clause contain buttons? Does it have a color? Does it have stripes? And for all of these categories, you get a score between 0 and 1. And concatenating all these scores together, you can get an embedding which you can put in a vector database for your vector search. It's kind of hard to scale because you need to do a specific model and labeling for each type of object. And I really wonder how Google Lens does. Because, I mean, they work, like their algorithm work very well. So are they working more like with this kind of fine-tuning or this kind of fine-tuning? So if anyone had any thought on that or any idea, again, I'd be happy to talk about it afterwards. And finally, I feel like we made a lot of advancements in multimodal training, trying to combine text inputs with image input to like build some kind of complex embeddings. And how great would it be to have an image embedding you could guide with text? So you could just, like, when creating an embedding of your image, just say, all right, here I don't care about the movements, I only care about the features on the object, for instance. And then it will learn an embedding according to your task without any fine-tuning. I really feel like with the current state of the arts, we are able to do this. I mean, we need to do it, but the technology is ready.
Can I ask a
The
few
second use
questions
case,
before you jump into the second use case?
yes.
What other models were you looking at besides the Dino one?
Um, I said here I compared to ResNet, efficient nets, and this kind of architectures.
Is was maybe this was too early, or maybe it's not actually valuable. What was that like segment anything? Was that did that come into the play?
So segment anything, I don't think they really do embeddings. It's really about segmentation. So here I was just showing the segmentation part because it's a cool outcome of the model and it shows
Oh,
that the
okay.
model works well. Here we are really here to build a representation of the image.
Uh-huh.
We cannot really play with segment anything for the matching,
Yeah,
to
makes
my
sense.
knowledge at least.
And then on the next slide where you talked about things you would do differently, or the last slide, I guess, the areas of
Yes,
improvement, you mentioned label hard examples for fine tuning. And I feel
yes.
like, yeah, there's one way of doing it, which is you hand picking the different embeddings that you think are going to be hard. And then there's another one where I think there's tools out there now that can kind of show you where there are different embeddings that aren't doing so well or that are more edge cases.
Which tools are you talking about?
I don't I don't remember the names, but I definitely have seen like demos online about how it'll give you a 3D space and you can kind of explore the different embeddings and explore what's going on
Yeah, yeah.
and all
So I
that.
know exactly what you're talking about. Actually, so TensorBoard embeddings is a good tool for that. I could actually demo it afterwards.
Yeah. I don't want to get you
But
off track. I was just
yeah, yeah. So
that's
it
something
has
that
some
came to
time at the end.
mind. Yeah.
But TensorBoard, I mean, if you're talking about the same tool, TensorBoard embedding. So basically, you have an embedding of like 1,000 dimensions, and it just reduces it to like three dimensions. And so you can visualize it in a 3D space and you can see how close your embeddings are from each
Yeah,
other.
exactly.
But it's really for like visualization purposes, not really for like for training purposes.
Uh-huh. Yeah, okay. I see. I
If,
see.
if,
Good.
if we're talking about the same thing.
Yeah, I think that that sounds like what I'm talking about. So good to know on both of these, and you're shooting me straight on it. Mike is asking a question in here, like text embedding. Would that allow you to include an image with alternate text?
An image with alternate text. I'm not sure I understand the question.
So it sounds like a way to meet regulatory accessibility requirements. If you have, I think it was probably around the where you were talking about the multimodal and text to guide the embeddings and
Yes,
potentially
yes.
like
Yes,
would having that allow you to include an image with alternate text?
include. So the idea is not to. I feel like the question is about inserting text within the image.
Oh,
So
hmm.
it's what I understand. So basically, my idea was just if you could create an embedding that could combine a text input and the image inputs, and basically it would be trained in such a way that the text would basically be used as a guidance of the image to only encode the parts of the image which are required for your task to not be disturbed by the noisy things.
Okay. Yeah, yeah. All right. Mike, let us know if that answers the question or if you have more. Yes, he's saying, yeah, inserting text with image for people who can't see.
Okay, cool.
Yeah, right on. So
Uh,
I'll let you keep cruising and I'll try not to derail it again, but that was great. It was just so pertinent. I wanted to stop
no
you and
worries, no
ask some
worries.
questions.
No worries. Let's just move in. So, the second use case is about deduplicating real estate adverts. So, as I was saying, you have two agencies coming to take different pictures of the same property, and the thing is that they may not put exactly the same price or the same surface or the same location, so you cannot just match them with metadata. So what our client was doing beforehand, and he kind of built a huge if machine, which is like, all right, if the location is not too far, and if the surface is not too far, and the price, and it was just like very complex rules. And at the end, there were a lot of edge cases. It was very hard to maintain. So it was like, let's just do a simpler solution, just based on images. So yeah, so it was basically the task to match images of the same properties. Again, on the positive outcomes is that the Dino really managed to understand the patterns of the properties without any fine tuning, and it was resilient to read different angles of the same room. So like on the pictures I just showed, the model was quite good at identifying it was from the same property. Here we used Qdrant for this project. It was a bit more recent. We leveraged a lot the metadata filtering because, of course, we can still use the metadata even if it's not perfect, just to say, all right, only search vectors which are a price which is more or less 10% this price, the surface is more or less 10% the surface, etc., etc. And indexing of this metadata, otherwise the search is really slowed down. So we had 15 million vectors, and without this indexing, the search could take up to 20, 30 seconds, and with indexing, it was like in a split second. So it was a killer feature for us. And the quantization, we use quantization as well to save costs, because the task was not too hard, since using the metadata, we managed to every time reduce the task down to a search of 1000 vector. So it wasn't too to quantize the vectors, and at the end, for 15 million vectors, it was only $275 per month, which with the managed version, which is very decent. The challenges we faced was really about bathrooms and empty rooms, because all bathrooms kind of look similar. They have like very similar features, and same for empty rooms, since there is kind of nothing in them, just windows. The model would often like put a high similarity scores between two bathrooms of different properties, and same for the empty rooms. So again, the method to overcome this thing will be to label hard pairs. So example were like two images where the model would think they are similar, to actually tell the model no, they are not similar, to allow it to train to improve its performance. And again, same thing on the future of image embedding. I really think it's something the technology is ready for, and would really help this kind of embedding model. Jumping onto the text search projects. So the principle of retrieval-augmented generation, for those of you who are not familiar with it, is just you take some documents, you have an embedding model, here an embedding model trained on text images, which will output representations from these documents, put it in a vector database, and then when a user will ask a question over the documentation, it will create an embedding of the requests and retrieve the most similar documents. And afterwards, we usually pass it to an LLM, which will generate an answer. But here in this talk, we won't focus on the overall product, but really on the vector search part. So the two projects was one, as I told you, a RAG for my Notion company, so a Notion with around a few 100,000 of pages. And the second one was for a medical company, so for the doctors. So it was really about the documentation search rather than the LLM, because you cannot output any mistake. The model we used was OpenAI Ada-2. Why? Mostly because for the first use case, it's multilingual, and it was off the shelf, very easy to use. So we did not spend a lot of time on this project. So using an API model made it just much faster. Also, it was multilingual, approved by the community, etc. For the second use case, we're still working on it. So since we use GPT-4 afterwards because it's currently the best LLM, it was also easier to use Ada-2 to start with. But we may use a better one afterwards because as I'm saying, it's not the best one. If you refer to the MTab, so the massive text embedding benchmark made by Hugging Face, which basically gathers a lot of embeddings benchmark and such as retrieval, for instance, and so classify the different model for these benchmarks. It has some. The MTab is not perfect because it's not taking into account cross-language capabilities. All the benchmarks are just for one language, and it's not as well taking into account most of the languages. Like it's only considering English, Polish, and Chinese. And also, it's probably biased for models trained on closed source datasets. So, like most of the best performing models are currently closed source APIs and hence closed source datasets. And so we don't know how they've been trained. So they probably trained themselves on these datasets. At least if I were them, it's what I would do. So I assume they did it to gain some points in these datasets.
So are
Uh,
you both of these rags are mainly with documents that are in French?
yeah, so this one is French and English, and this one is French only.
Okay, yeah. That's why the multilingual is super important for these use cases.
Exactly.
Yeah.
But again, for this one, there are models for French working much better than Ada-2, so we may change it afterwards.
Uh-huh.
But right now, the performance we have is decent. Since both projects are very similar, I'll jump into the conclusion for both of them together. So Ada-2 is good for understanding diverse context, a wide range of like documentation, medical contents, technical content, etc., without any fine tuning. The cross language works quite well, so we can ask questions in English and retrieve documents in French and the other way around. And also, quick note, because I did not do it from the start, is that when using an API model, it's much faster to use it in asynchronous mode. Like the embedding creation went something like 10 times or 100 times faster. So it was definitely, it changed a lot of things. Again, here we use Qdrant mostly to leverage the free tier. So they have a free version, so you can pop it in a second, get the free version, and using the feature which allows to put the vectors on disk instead of storing them on RAM, which makes it a bit slower. You can easily support a few hundred thousand of vectors, and with a very decent response time. The challenge we faced is that mostly for the Notion, so like mostly in Notion we have a lot of pages which are just a title or which are full because they are empty, etc. And so when pages have just a title, the content is so small to a question. Um, so often the documents which were retrieved were documents with very little content, which was a bit frustrating. Chunking appropriately was also tough. So like basically, if you want your retrieval process to work well, you have to divide your documents the right way to create the embeddings. So you can use Métier rules, but basically you need to divide your documents in content which semantically makes sense, and it's not always trivial. And also for the RAG for the medical company, sometimes we are asking questions about a specific drug, and it's just not our search is just not retrieving the good document, which is very frustrating because a basic search would. So to handle these challenges, um, a good option would be to use models handling differently questions and documents like BG or Cohere. Basically, they have been trained. They use the same model but trained differently on long documents and questions, which allow them to map them differently in the space. Is that using such model, um, documents which are only a title, etc., will not be as close as the question as they are right now because they will be considered differently. So I hope it will help this problem. Again, it's just a guess. Maybe I'm wrong. Hybrid search. So for the keyword problem I was mentioning here. So in the recent release, Qdrant just enabled sparse vectors, which make actually TF-IDF vectors possible. So TF-IDF vectors are vectors which are based on keywords, but basically there is one number per possible word in the datasets. So and a lot of zeros. So storing them as a normal vector will make the vector search very expensive, but as a sparse vector, it's much better. And so you can build an hybrid search combining the TF-IDF search for keyword search and the ADA search for semantic search to get the best of both worlds and overcome this issue. And finally, I'm actually quite surprised that with all the work that is going on generative AI and RAG, nobody has started working on a model to help with chunking. Well, it's like one of the biggest challenge. And I feel like it's quite doable to have a model which will, or a model or some kind of algorithm which will understand the structure of your documentation and understand why it semantically makes sense to chunk your documents.
Dude, so good.
So,
Wait,
so yeah,
I got
so just
questions. I got
yeah.
questions coming up. Don't go anywhere. Actually, it's not just me. Tom's also got some questions, so I'm gonna just blame it on Tom, throw him under the bus. Uh, RAG with medical companies seems like a dangerous use case. You can work to eliminate hallucinations and other security safety concerns, but you can't make sure that they're completely eliminated, right? You can only kind of make sure they're eliminated. And so, how did you go about handling these concerns?
This is a very good question. This is why I mentioned this project is mostly about the document search. Basically, what we do is that we use Chainlit, which is a very good tool for chatting, and then you can put a React front in front of it to make it very custom. And so when the user asks a question, um, we provide the LLM answer more like as a second thought, like something the doctor could consider as a second thought. But what's the most important is that we directly put the instead of just citing the sources, we put the HTML of the pages the source is based on, and what bring the most value is really these HTML pages. And so we know the answer may have some problems. The fact is based on documents. Hallucinations are almost eliminated. Like we don't notice any hallucinations, but of course they can happen. So it's really the way it's really a product problem rather than an algorithm problem, an algorithmic problem.
Yeah. So now,
So it's really putting forward the documents retrieved rather than the LLM answer.
yeah, makes sense. My question around it is like a lot of times in the medical space, the data that is being thrown around is super sensitive, right? And you have a lot of PII. How do you navigate that? Are you just not touching that? And
No, so basically we work with a provider in front which has public documentation. So it's public documentation. There is no PII.
oh, okay, cool. So it's not like,
Some of it is private, but still there is no PII in this in their documents.
yeah, because I think that's another really
Yeah, of
incredibly
course.
hard problem is like, oh yeah, we're just sending all of this sensitive information over to the IDA model to create embeddings with it, and then we also pass
Yeah,
it through
yeah,
ChatGPT before we get it back. And next thing you know, that is the data that was used to train GPT-5, and you can
yeah,
say
exactly.
things like create an unlimited poem and get that out of it. So it's super sketchy, right?
Yeah, of course. One way to overcome that is to, for instance, for the Notion project, it's our private documentations. We use Ada over Azure, which guarantees data safety.
Yeah, yeah.
So it's quite a good workaround. And when you have to work level of security, if you deal with PII, a good way is to play with metadata. So depending on like the security level of the person who has the question, you play with the metadata to output only some kind of documents.
Mm-hmm.
The database metadata.
Excellent. Well, don't let me stop you. I know you had some conclusionary
Whereas
thoughts there.
I was no, whereas I was about to conclude. So anyway, so just to wrap it up, so we got some good models with the without any fine tuning. With the model we tried to overcome them, to overcome these limitations we still faced. For image search, fine tuning is required at the moment. There is no really any other way to overcome it otherwise. While for text search, fine tuning is not really necessary. It's more like tricks which are required about like using hybrid search, using better models, etc. So two kind of approaches. Qdrant really made a lot of things easy. For instance, I love the feature where you can use the database as a disk file. You can even also use it in memory for CI integration and stuff. But like, since for all my experimentations, etc., I want to use it as a disk file because it's much easier to play with. Um, I just like this feature, and then it allows to use the same tool for your experiments and in production. When I was playing with Milvus, I had to use like different tools for experimentation and for the database in production, which was making the technical stock a bit more complex. Sparse vector for TF-IDF, as I was mentioning, which allows to search based on keywords to make your retrieval much better. Manage deployment. Again, we really struggle with the deployment of the, I mean, the DevOps team really struggled with the deployment of the Milvus. And I feel like in most cases, except if you have some security requirements, it will be much cheaper to use the managed deployments rather than paying dev costs. And also with the free cloud and on these vectors, you can really do a lot of start a lot of projects. And finally, the metadata filtering and indexing. So we by the way, we went into a small trap. It's that indexing. It's recommended to index on your metadata before adding your vectors. Otherwise, your performance may be impacted. So you may not retrieve the good vectors that you need. So it's an interesting thing to take into consideration. I know that metadata filtering is something quite hard to do for a vector database, so I don't really know how it works, but I assume there is a good reason for that. And finally, as I was mentioning before, in my view, new types of models are needed to answer industrial needs. So the model we are talking about, text guidance to make better image embeddings, and automatic chunking, like some kind of algorithm or model which will automatically chunk your documents appropriately. So thank you very much. If you still have questions, I'm happy to answer them. Here are my social media if you want to reach out afterwards. And all my writing and talks are gathered here if you're interested.
Oh, I like how you did that. There is one question from Tom again asking about if you did anything to handle images and tables within the documentation when you were doing those rags.
No, so I did not do anything for the images. And for the tables, it depends. When they are well structured, I kept them because the model manages to understand them. But for instance, we did a small POC for the medical company when we tried to integrate some external data source, which was a PDF, and we wanted to use it as an HTML to be able to display the HTML as I was explaining to you directly in the answer. So we converted the PDF to HTML, and in this conversion, the tables were absolutely unreadable. So even after cleaning, so we did not include them in this case.
Great. Great. Well, dude, thank you so much for coming on here, and thank you all for joining us for yet another Vector Space Talk. If you would like to come on to the Vector Space Talk and share what you've been up to and drop some knowledge bombs on the rest of us, we'd love to have you. So please reach out to me. And I think that is it for today. Noé, this was awesome, man. I really appreciate you doing this.
Thank you, Demetrius. Have a nice day.
We'll see you all later.
Bye.